Hello everyone. Good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 2C. Myself, Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GR Scholar 6 LLP as an international organizational technical partner, Trinity University as a university partner, Venovage DMC as a local organization or MICE partner, and Springer and Sprinter as
Please partner.
It is my great pleasure to welcome you all to the 8th International Conference on Information and Communication Technology for International Systems, ICTIS 2024, Las Vegas, USA. The 8th edition of the conference is being organized in the hybrid mode. The physical event was organized in Las Vegas, USA on 23rd May 2024, and the virtual event is being held through Zoom today, that is 24th May 2024. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or any kind of updates, then you can write it to me in the chat box below. Just before we get started, I would like to introduce you to the chair of the session, Dr. Muhammad Feroz Mridha, Associate Professor, American International University, Bangladesh. Sir is a senior member of IEEE and is currently working as an associate professor in the Department of Computer Science at American International University, Bangladesh. His research interests include artificial intelligence, machine learning, deep learning, and natural language processing, that is NLP. Also, I would also like to introduce you to our next session chair, Dr. Preeti Parvekar, Associate Professor, SRM Institute of Science and Technology, Ghaziabad, India. Ma'am is an associate professor in the Department of Computer Science and Engineering, Faculty of Engineering and Technology. She has been an academician from last 20 years. Her research interests include Internet of Things, cloud computing, machine learning, wireless sensor networks, software engineering, information retrieval systems, social media, and data mining. Welcome to the session, ma'am and sir. Would you like to share a quick opening remarks with us?
Thank you, Anisha. I hope I'm audible.
Yes, ma'am, you're audible.
Thank you so much for the introduction. And I welcome all the presenters to the conference of ICTIS and wish you all the best. And I think we should start the conference. The presentation with the first author.
Okay. So now I would like to call our first author. That is Luis Castillo Sirlex. Sir has to present the paper titled A Comparison Between Angular and React Native Frameworks Used in the Development of MIES APA mobile application. Are you there, sir?
Yes, I'm ready to share my
You may
my
start
screen.
your presentation, sir.
Yes.
Can you share your screen now, sir?
Yeah, I'm ready. You can see?
Yeah,
the presentation?
sir. Yeah, you may
Yes.
please start with the presentation.
Okay. So, thank you for the presentation. Good morning to everyone present in this room. I'm going to talk to you about our research title, A Comparison Between Angular and React Native Frameworks Used in the Development of the MIES app mobile application. The content of this
We can see your screen, sir.
Yes, okay. I can pass the slides. Yeah. Okay, the content of this presentation will be the introduction, the background, the methodology, the results, and discussion. And finally, I tell you the conclusions we have. For the research problem, the analysis of web and mobile application development frameworks is a critical area in the current technological context. With the constant proliferation of available options, a fundamental question arises. Which framework should we select for our development projects? Although the answer to this question may lack absolute accuracy and depend largely on project-specific consideration. The objective of the study was technically compare the Angular and React Native frameworks used to develop hybrid applications. Both frameworks were analyzed, describing their features, advantage, and disadvantage. The relevance of this article lies in the analysis of capabilities offered by the select frameworks with an evaluative technical approach support by SonarQube tool. We seek demonstrate tangible results of the development applied through both frameworks in metrics such as errors, vulnerabilities, security, code duplication, number of line of code, cyclomatic and cognitive complexity. The research was conducted in the context of the mobile application MIES app developed to measure the degree of senile dementia in older adults in the province of Santo Domingo de los Áchilas. This specific context provides a real scenario for development in two applications with characteristics. And for this study, the widely used hybrid frameworks, Angular and React Native, were selected. Both Angular and React are hybrid application development platforms with inherent differences. A comparison of the use of each of these development platforms can be seen in this figure, where the statistics of the NPM trends show the preference of downloads in the last 2 years, which is increasing in favor of React Native. This figure, on the other hand, shows the search trend over last 2 years according to Google Trends. Angular outperforms React Native in the number of searches. So, to carry out the comparison between two leading frameworks, two applications were developed in different environments. The first application developed with the React Native framework was part of the project of linking with society. Here is the name of the project. This project involved the development of a mobile application that allows technicians to conduct for service of older adults, automate the process for quick results. The Android application package, APK, was uploaded to the Google Play Store mobile application and delivered in April 2022 by the project manager. The development of the application in this project was carried out in 3 phases, with 2 teams in each phase. In the church, one in charge of the front end using the React Native framework, and another group responsible for backend, which implement the web services using Node.js and manage the database in MySQL. The entire backend is hosted on a physical application server at the Universidad de las Fuerzas Armadas de ESPE, sede Santo Domingo, exposing the web services through a public IP. The architecture of this application can be visualized in this slide. The second application was developed with the Angular framework using as a reference the application previously developed with React Native for comparison purposes. This development was done by a different team and was part of partial projects in the subject Advanced Programming of the Information Technology Engineering degree. The application was developed in two phases, corresponding to the first two partial periods of the semester. The students of the subject designed the interfaces of the entire application in the first partial. In the second partial, students create the database using MongoDB and to access the data remotely. In addition, in this second partial, the necessary web services were created to manage the application data using a Node.js server hosted on an EC2 instance of the Amazon Web Service platform and communicating directly with the MongoDB Atlas database, also located in the cloud. The architecture of this application can be visualized in this slide. This second application has the same operation as the first one, which allows considering the same characteristics of the application for the comparison of the frameworks. With the two applications developed, it was possible to perform the analysis of their source code using SonarQube, an open source platform for code quality inspection. This platform provides metrics that help improve the quality of a program's code, allowing development teams to track and detect bugs and security vulnerabilities to optimize and keep the code clean. First, SonarQube evaluates the reliability feature of the source code according to the presence of bugs and their importance. Angular received a D grade for reliability due to 19 major bugs and 30 minor bugs. React Native received a C grade with 13 major and 13 minor bugs. No vulnerability were found in the source code of both applications. This resulted in a security rating of A for both applications, the highest possible. SonarQube also evaluates security hotspots, which are another measure of source code security. Angular report 11 security hotspots, while React Native report 27, leading to an A grade for security review for both. As for maintainability characteristics, two measures are considered: code smells and technical depth, expressed in days and hours. Angular had 99 code smells and 1 day of technical depth, while React Native had 236 code smells and 2 days and 5 hours of technical depth. Both received an A grade for maintainability. In terms of source code length, Angular had 5,200 lines of code with
Sorry to
13
interrupt,
point,
sir. Sorry to interrupt, sir, but you have 2 minutes to conclude your presentation.
uh, 13.10% duplication, while React Native had 10,000 lines with 9.9 duplications. SonarQube provides a detailed analysis of several source code characteristics, including cyclomatic and cognitive complexity. Angular's cyclomatic complexity was 431 and cognitive complexity was 286. React Native's cyclomatic complexity was 897 and cognitive complexity was 429, almost twice as complex to understand. In conclusions, over the past 2 years, React Native has seen significant growth in downloads, but Angular remains more popular in terms of searches. A SonarQube analysis shows variable software quality in apps developed with both frameworks. Angular excels in security hotspots, code smells, technical depth, and lines of code, while React Native stands out in bugs and duplications. And both frameworks show excellent security ratings with no code vulnerabilities, thanks to the implementation of the MVVM architectural pattern. While neither framework has an absolute advantage in SonarQube's main features, it's important to consider cyclomatic and cognitive complexity. React Native apps have a higher logical complexity and require more test cases, while Angular apps have longer cognitive complexity, making them more intuitively accessible. And thanks for your attention.
Thank you so much, sir. Ma'am, do you have any questions?
Yes, I have two questions, but before that, I just wanted to say hello to Milan Tubo. Are you there, Professor Milan? He was there, I guess. He had just come. Eva and Milan, I just saw. All right. So, Luis, I have two questions for you. Yeah, the first thing is, how have you tested your mobile app?
Sorry, can you repeat
Testing,
the question?
testing of this mobile application, how have you done it?
No, I can't
Am I clear with the
understand
question?
you. Sorry.
Anisha, can you
Uh,
please repeat the question for my side?
Ma'am is asking, how have you tested your mobile app? How have you done the testing of your mobile app?
Okay. We test the mobile application using SonarQube for the code, but we okay, in the project of linking by society, they test the application with the technicians to make the service to the old people. In the other case, in the mobile application developed with Angular, we test the application with students, only with the students. So this is the comparison we have in the two in the two mobile apps.
All right, Luis, thank you for the presentation. I think we can move to the next presenter.
Okay, thank you.
Next up, we have Anupama Singh to present her paper titled Blockchain-Based KYC, Content Untraceable, Storage and Encryption. Are you there, ma'am? Are you there, ma'am?
Yes, I'm here.
Yeah. You may start with the presentation, ma'am.
Yeah, thank you. Okay, I'll just share my screen. Is my screen visible?
Yes, ma'am. Your screen is visible. You may start.
Okay. Okay, so good morning to one and all. I'm Anupama Singh, student of Tedna Engineering College, Department of Computer Science from University of Mumbai, India. Today I am presenting on the topic blockchain-based KYC, content addressable storage, and encryption. So here's the flow of my presentation. We'll be looking into introductions, literature survey, the research gap, problem statement, the methodology I've used, the proposed work, results and discussion, and concluding. So KYC system is know your customer or client system, and it is a process of verifying the identification of the customer. So the problem with KYC system is that it is centralized, and which leads to the single point of failure. And KYC data is a crucial data or information, and it can get exposed or leaked to the hackers. So the solution to this problem is the blockchain technology or the blockchain based KYC. So blockchain is the distributed here, blockchain is the distributed or decentralized immutable ledger, which records transactions and assets over a network. Here you can see the diagram of the blockchain, Ethereum blockchain, and it has certain components like timestamp, Merkle root, nouns, etc. And I have also used make use of the IPFS interplanetary file system component, which is the content addressable storage, in which the data is stored based on a content rather than the location. It makes it unique, and it provides and ensures data integrity. And as for the encryption point of view, I'll be discussing that in the further slides. So here's the literature survey. So I've conducted the literature survey of the several papers, and I have come to the conclusion like here that summary is written for the certain papers as well as the limitations. So the limitations of these current systems is that many of the papers have some certain privacy or security concerns, scalability or portability issues, and in some papers there is absence of encryption and decryption mechanism as well. So what these issue makes the system very vulnerable, and it is more prone to attacks by the hackers. So the research gap can be summed up as absence of cryptographic measures like the encryption and the decryption mechanism. Then scalability issues like KYC system getting stored takes up a lot of space. And it is not ideal for the large files like the KYC. So scalability issues comes. And there's also a lack of economical KYC system in terms of cost saving and storage. So the problem statement is like that several issues like the lack of data integrity, centralized control of data. So this leads to limited access of data and expensive storage costs. Also, the absence of encryption and decryption mechanism is taken into concern here. So to solve and address these issues, we have proposed a blockchain-based KYC system, which is having content addressable storage and encryption using AES 256 GCM algorithm, which is the advanced encryption standard with Galileu's counter mode. And the 256 here stands for the 256-bit key, which is getting encrypted from the plain text. So now the proposed work on the proposed system is divided into three components here, as you can see. The first one being the user or the customer flow. Second being the system flow, and third is the data retrieval by the user. So the user starts out by filling the form, and he or she fills out the personal details and attaches the document, identity related documents, and sets the password, ticks the declaration that he or she is submitting the authentic data, and submits the form. Thereafter, the submitted data gets encrypted using the AES 256 algorithm, and it is sharded or hashed into 256 bits. That means that simply means that the data is converted into the bit of 256 length and put into IPFS storage. And it is returned as a unique content identifier, that is CID, which is then stored into the MongoDB database with the metadata. And it is then the metadata and the IPFS is then stored to the blockchain after it returns that the transaction is successful. Now, if the user wants to retrieve the data, what they can do is provide the user credential, that is the wallet address and the password to access the data, and it will be fetched from the blockchain and hashed. So after which user IPFS gateway will reconstruct the 256 bit of data and return the decrypted data, and after which the plain text can be viewed by the user. The methodology which I have followed is the RPC call to decentralized network through wallet signer, that is the MetaMask wallet. Here what is happening is the remote RPC, the remote procedural call, allows the application to communicate with the blockchain to execute the function. So the wallet, like the MetaMask wallet, acts like an intermediary between the application and the blockchain. Here you can see the application initiates the RPC call, after which the request is sent to the wallet, that is the MetaMask wallet, and the user signs, the wallet interacts with the user, and the MetaMask, that the wallet asks the user to confirm the details like the amount, transaction amount, and the recipient address, after which the user gives approval. The MetaMask signs the transactions using a private key, and it is sent to the node on the Ethereum. The node gets processed and it is put on the network. And the encryption and decryption is being done using the AES 256 GCM algorithm. So in very simple terms, after the data is submitted into the wallet as plain text, the data gets encrypted as the cipher text, which is of 256 bit length. And this is where the process ends. And as for the decryption part, if the user wants to access the data, what they can do is put the wallet credentials like the wallet address and the password, and the data gets decrypted into the plain text, and they can view the same. Now, results and discussion. I have done the comparison of traditional other blockchain systems and our proposed system. So here I've taken a traditional KYC system, the system made in paper number 6, which I've referenced, 8, 10, 11, and finally our proposed system. So I've evaluated them based on the attributes given here, and whether the system they are using is blockchain based, whether they have an access control, do they have a secure search, what kind of storage environment they are using, and what encryption and decryption mechanism they are using. So for traditional KYC system, it is not a blockchain based, it's simple digital. Then they don't like the traditional KYC system does not have a secure search or a access control or encrypted decryption mechanism. As for the system used in paper number 6, it is a blockchain based and they're using Ethereum blockchain. It does have access control and secure search, and storage is dependent on the organization's choice. So as for in paper number 8, there's this, it is a blockchain based, and as for access control, it is done on the private blockchain structure. It does have a secure search, as they say, and for storage environment, they are using content addressable storage and Merkle tree. And for the encryption, they are using hash SHA. In the paper number 10 and 11, they both are distributed ledger technology. Yes, that means it is a blockchain based. They both have secure search, and for storage environment, they both are using content addressable storage. But as for access control, in paper number 10, they are using some kind of third party verification, and in 11, it's hash value. Paper number 10 does not have a mechanism for encryption and decryption, whereas in 11, it's GPG for Win. This is a software for Windows through which an email encryption and decryption takes place. And as for our proposed system, it is Ethereum blockchain based, and access control is done through document password. Secure search is done where the data is hashed and mapped to the certain account address in the smart contracts. And as for storage environment, it is done. It is put on MongoDB database and peer-to-peer file system. That is the IPFS. And we do have both encryption and decryption mechanism in our system. So that is AES 256 GCM algorithm. So now moving ahead, now we'll be discussing the data uploading cost on the blockchain in US dollars. So generally what happens in most of the cases, the data is being uploaded onto the blockchain as raw data. Raw data here is just simply the metadata, which is in which the file, through which the file can be identified. But what we are doing in our system is using converting the metadata into the encrypted data, and then we are uploading. So what happens here is, as you can see, the data size is increasing from 1 byte, 1 kilobyte, and it goes up to higher to 1 megabyte. And in this column, the second column, cost of uploading the raw data. The standard is given in Ethereum docs, that is 0.0006, and it is increasing up to $19. And in our system, the cost of uploading the encrypted data is uniform because each and every data is converted into the 256-bit length encrypted data, and then it is put onto the blockchain, which helps a lot in storage space, and it is more economical as well. So here in the graph, as you can see, the x-axis denotes the data size, whereas the y-axis is data uploading cost on.
Sorry to interrupt you, ma'am, but you have 2 minutes to conclude the presentation.
Yeah, sure. So cost on blockchain. So here cost of uploading the raw data is increasing, which is not feasible and it is not affordable. Whereas in our case, where the encrypted data is being put to the blockchain, it is more feasible, more affordable, inexpensive, and more economical, which makes it very adoptable to the industries which want to adopt this system. So now I'd like to conclude my presentation by saying that integration of the KYC system with the blockchain technology offers a very robust system as it addresses the security and privacy concerns. And practical examples where blockchain-based KYC systems are already in existence are in the countries like the UAE and Singapore. So, and the future scope or the future work which we intend on doing with the proposed system is the use of rollups in our system. So a brief description about rollups is that where multiple transactions will be bundled together off chain and it will be processed efficiently, and then it will be settled to the final network. What it will do, it will further speed up the transaction process and reduce the transaction fee further less. So these are the references I've used. Thank you.
Yes,
Thank you
Anupama.
so much, ma'am. Ma'am, do you have any questions or sir? Do you have
Yeah.
any questions?
Sir, would you ask the questions first, or shall I ask?
Can I please stop sharing my screen?
Yes, please. Anupama, can you hear me?
Yes, ma'am, I can hear you.
Yes. Anupama, there are some questions for you. It's a good work, no doubt. Now, when you are using Ethereum blockchain,
Yes, ma'am, yes.
Ethereum is generally complex to use. So,
Yes,
may
ma'am.
I know why did you choose Ethereum?
Ma'am, Ethereum, actually, it being the pioneer in the blockchain industry, because thereafter we had different blockchains as well, like the Polygon and the Solana as well. But it is comparatively more easier to use, and like private companies can use like, things like account abstraction instead of MetaMask. So even that adoption is more, and the number of users onboarded in the Ethereum is quite high compared to the other new blockchain. So that's why I've used.
All right. And there was one more aspect of security. You said ki we have compared the security, but when you use Ethereum, there is a threat of Lido, if you have heard of it.
Okay.
So have you considered about it?
Lido ma'am, can you just is it
There is a protocol threat for the Ethereum,
okay?
which comes in the security part. You can study that further
Mm-hmm.
and look for the solution, whether that particular threat is there with your blockchain Ethereum or not. Does it affect your things?
Okay, ma'am. Like if an hacker wants to hack Ethereum, like he'll have to get control of the 51% of the computers on the network, which is very, very costly, and like it is not possible to do so. So even then it would not be possible to change the already made and put already made transactions. So it's not possible. But I'll look into it and study more about it.
Yeah, and one last question is about the storage part. So how have you considered the storage and how much storage does it support your system? Because it
Yes.
is distributed, so how are you doing about it?
Yeah, so as for storage, the I have used the IPFS nodes and the Ethereum node for the storage, and through that we can get the real indication of the costs, gas fees, right? And yeah, ma'am. So
All right.
yeah.
Any other question from the other session, Chair?
So I think we should move to the next presentation.
All right.
Next up, we have Tahani to present her paper titled Deep Learning Based Recognition System for Libyan License Plates. Are you there, ma'am? Are you there, ma'am?
Yeah, she's online. We can see her.
I'm here.
Yeah. Okay, ma'am. You may start with the presentation, ma'am.
Okay, just 1 minute. I will try to show. Is it visible?
Yes, ma'am. It is visible. You may start.
Okay. Hi, everybody. My name is Tahani, and I'm so happy to be with you in this event today. I will be presenting a research work titled as Deep Learning Based Recognition System for Libyan License Plate. The outlines I will go through will be introduction, literature review, deep learning in automatic license plate recognition, proposed system, result discussion, and finally the conclusion. So as we all know, increasing number of vehicles poses challenges for traffic management and security. And the manual monitoring is becoming impractical, so automatic solutions are needed. Our objective for this research is developing a system to recognize Libyan license plate using deep learning technique. For the literature review, actually, I'm just going to mention the first automatic license plate recognition system, which is published in UK in 1976. And since there, a lot of research have been introduced, which depends on all on three main stages. First stage is license plate recognition. Second stage is license plate segmentation and license plate recognition. The challenges with all systems it depends on various factors. Sometimes it depends on the real world conditions, diverse plate formats, and also some conditions related to the varying light. So based on that, in the view last years, like deep learning have been used a lot in the field of object detection. And actually, there is an increase in the accuracy of detecting the objects in all the detection area, especially with the car plate. One of the most popular used techniques is YOLO, which is abbreviation of you only look once. It's efficient real-time object detection. And one more advantage is that it integrates the candidate area selection and target recognition. So instead of having 3 stages in the system, we just have 2 stages. So there's a kind of merging the first and second vases in just one vase. One of the popular models used for the detection, the license plate, in the last few years were YOLO and RoboFlow. And in this research, in our proposed system, we are going to recognize Libyan license plate using YOLO 8 and RoboFlow. So it's kind of comparison between those 2 tools and check which accuracy will be higher. So for YOLO version 8, it was when we conducted the research, it was the latest version actually, but in maybe a few months, there is another version which is YOLO version 9. And for the RoboFlow, it supports various computer vision tasks, including object detection. After detecting the license plate, we move to the last stage, which is character or recognizing the license character. In this stage, we use easy OCR for performing this task. As we can see in our proposed system, we first start with pre-processing the data set. And after that, we have 2 experiments. We can just mention or recognize them like 2 experiments. In the first experiment, we use YOLO version 8. In the second one, we use RoboFlow object detection. After doing the complete process of training and testing, we move to another small stage or sub-stage where we compare the result from the 2 technique, and after that we take the result to the last stage, which is plate character recognition. So for the data collection, we used 2,400 images of Libyan car plate, and in fact we collected only 1,000 images from various sources, and we used RoboFlow to duplicate this number of images. So it's kind of using diverse conditions, diverse lighting, and adding some noise to increase the number of images in the data set. In the pre-processing, we used the RoboFlow to increase, as we said, the data set. So we add noise, we make some rotation and resizing, brightening and contrast adjustments. For the training, as we have 2 experiments, so we already mentioned that we used YOLO 8 and RoboFlow. For the training part, 70% of the data set were used for training, 20 for validation, and 10 for testing. The hardware, we just use it like Navida with a 12 gigabyte RAM. The challenges, we are aware of the challenges we have, which is the data science, and some problems regarding the quality of the images, and that because of many problems in the plates in Libya. The main reason behind that is the lack of maintenance system here. If we look at the results, we can see this is the result of the YOLO version 8. So we use it to matrix parameter or matrix equations to compare the results. So we use it precision and recall. For YOLO version 8, we get 99.5, and for the precision 79. For the RoboFlow, we obtained better results. So it's 100% for recall and 99% for precision. Our concern was about the last stage, which is recognizing the letters we extracted from the license plate. As we use it easy OCR, we just got accuracy around 64.6, which is considered not that good for the last stage. So to summarize the discussion, in the detection performance, RoboFlow outperformed YOLO version 8 in precision and recall. For the character recognition, Easy OCR struggled with the specific fonts and damaged plates. For the future work, we are going to explore alternative OCR methods to try to improve the accuracy of Easy OCR. And as a summary, we developed an ALPR system for Libyan plate. RoboFlow showed better performance in plate detection. Easy OCR need improvement for character recognition. As a future directions, we are going to enhance OCR accuracy and expanded data set and explore additional use case. So thank you for your attention, and if you have any questions, please.
Thank you so much, ma'am, for your presentation. So, ma'am, do you have any questions?
Yes, Tahani, thank you for the presentation. And now,
Yeah.
which deep learning model have you used in your paper?
Yeah, we used actually two, which is YOLO version 8 and RoboFlow.
YOLO version and RoboFlow would be the data set, am I right?
And no, they are the techniques. They are depends on the neural network.
All right, but have you followed the convolutional neural network for this? For classification of the images of the number plates?
Sorry, can you just repeat the question? I couldn't get it.
Have you used a convolutional neural network, that is CNN, for classification of the images?
No, not really, no.
Okay. Because the question was like, which deep learning model? So is it a comparison between YOLO 8 and RoboFlow?
Yes, ma'am.
All right. So when you compare, generally, YOLO will not give you a good accuracy and speed compared to the RoboFlow. So according to you, after the comparison, which one was the better?
RoboFlow was better.
All right. Good luck for your future research. Thank you.
Thank you. Thank you very much.
Thank you so much, ma'am. So
Thank
we're
you.
moving on to our next presentation. Next up, we have Li Huang to present his paper titled Performance Analysis of ELIPS-based CP APE with Optimized Decryption Functions. Are you there, sir?
Yes, I'm here. Thank
Okay,
you
so
for your
you will start
introduction.
with the presentation.
Yes, I will share my screen.
Yes, sir, your screen is visible. You may start now.
Yes, thank you. Um, Good afternoon, Chair and everyone. I would like to introduce myself. My name is Lê Hoàng Ánh from Okayama University. What I would like to present to you today is performance analysis of Alice-based CBAB with optimized decryption function. My presentation is divided into 5 sessions. Now, let's move to the introduction. As we know, the ciphertext policy attribute encryption is an advanced encryption. It not only encrypts data, but also attribute against asset control. It has various applications such as cloud storage, IoT, blockchain, etc. However, the CBAB relies on pairing-based cryptography with a security limited to 80 bits and is now outdated, making it vulnerable to attacks and unsuitable for modern cryptographic application. Therefore, in previous study, we already proposed an Ellipse CBAB scheme to increase the security level and performance of CBAB by implementing Ellipse library. The Ellipse-based CBAB include setup, keychain, encrypt, and decrypt function. The Ellipse-based CBAB increase the security level to 128 bits and enhance performance of more functions. However, decryption remains heavy, and we may know that decryption in Ellipse-based CBAB include mainly use pairing and inversion. Pairing operation include final exponentiation and Mueller loop. And therefore, we propose minimization methods to improve the decryption process in Ellipse CBAB by minimizing the number of final exponentiation. The optimization reduce the number of final exponentiation from 2n plus 1 to 2 and reduce the number of inversion from n plus 1 to 2. In this work, we evaluate and analyze the impact of the optimization on decryption function and compare the Ellipse-based CBAB with the improvement to initial and original version. Next session, we present the Ellipse-based CBAB. This scheme includes 4 main functions. In setup, it will generate the generated tree and random alpha beta. Then it will calculate the master key and public key. Follow the equation 1. In next function, the CBAB will generate a secret key for each user related to the number related to their attribute. And then in encryption, the algorithm will encrypt message under asset policy and output ciphertext. In decryption, firstly, if we check the secret key and asset policy, then it will calculate a zero follow the equation 4. And then if the algorithm will decrypt the encrypted message follow the equation 5. In equation 4, delta I, it means the Lorentz coefficient, and it is calculated follow the equation 6. In equation 4 and 6 so that the number of pairing and inversion is proportional to the number of attributes. Therefore, we aim to improve the decryption in Elite by CBAB by minimizing the number of final exponentiation and inversion. Therefore, in next session, we introduce two methods to improve the decryption function. First method, minimizing the final exponentiation. Equation 7 shows the decryption equation. And in this equation, we can see the number of pairing is proportional to the number of attributes. And the pairing, we may know that the pairing include Mueller loop and final exponentiation. Therefore, in first method, we aim to reduce the number of final exponentiation as follows. Firstly, we transform the decryption equation to Mueller loop and final exponentiation follow the equation 8. In this equation, we can see the final exponentiation is proportional to the number of attributes. Therefore, next step, we propose a transform equation to reduce the number of final exponentiation, follow the equation 9. In this method, we can see it only employs one final exponentiation at last step. And this method reduce the number of final exponentiation by 2n minus 1 times. Second method, minimizing the inversion. I mentioned the Laurent coefficient is calculated if follow the equation 10. In this equation, we can calculate inversion for each attribute. Therefore, in second method, we aim to reduce the number of inversion as follow. Firstly, we calculate the product AI, follow the equation 11, and then we calculate inverse of AI, follow the equation 12. And finally, we can calculate inversion and follow equation 13. In this method, we can see it only use one inversion as step 2. And this method reduce the number of inversion by n minus 1 times. Next, this slide shows the decryption cost comparison among CBAB scheme. It means original CBAB, and initial elite-based CBAB, and elite-based CBAB with optimized decryption. In this table, show that elite-based CBAB with the decryption optimization reduce the number of final exponentiation by 2n minus 1 time, from 2n plus 1 to 2, and reduce the number of inversion by n minus 1 time. It means reduce from n plus 1 to 2. In next session, we recent implementation and performance evaluation. Table 2 show the device and software that we use during our experiment. In the first experiment, we validate the decryption time. In this experiment, we use a set policy as shown in figure 1, and we fix the number of attributes at 10, and using various file size from 8 kilobyte until 96 kilobyte. And the figure 2 show the comparison of decryption time between initial elite-based CBAB and elite-based CBAB with decryption optimization. The results show that ellipse by CBAB with the optimization faster than initial version, 43.06%. And second experiment, in second experiment, we validate the total execution time. It means set include setup time, key generation time, encryption time, and decryption time. In this experiment, we're using asset policy tree for ISO in figure 3. And every step, we increase the number of attributes from 10 to 50. And in figure 4, show the comparison of total execution time among in its original BBC by CBIB, initial ellipse by CBIB, and ellipse by CBIB with decryption optimization. This figure shows that the ellipse by CBIB with decryption optimization is 25.27 faster than initial version and 53.81 faster than original version despite the higher security level. Now let's move to the conclusion. In this work, we assess the influence of ellipse-based CBIB with the decryption optimization. The results show that if the ellipse-based CBIB with the decryption optimization is 43.06 faster than decryption time compared to initial inversion, and 25.27 improvement total execution time compared to initial, and 53.81% improvement total execution time compared to original BBC by CBIB, while providing a higher 128-bit security. At the future work, we plan to integrate our proposal into the blockchain system to establishment of file asset control policy and enhance privacy, reserving distributed asset control. Thank you so much for your listening.
Thank you so much, sir, for your presentation. Ma'am, do you have any questions?
No. Thank you so for the presentation.
So next up, we have Fabio Marcosi to present his paper titled Real-Time Generation of a Targeted Clean Audio Sequence from Source Separation of Noisy Environmental Mixtures using a deep, non-negative matrix vectorization on IoT devices. Are you there, sir?
Okay, nice to meet you. Thank you very much. Okay, can you hear me?
Yes, sir. You may start with your presentation.
Okay, great. So I start immediately. I share my screen. And here we are. So my name is Fabio Marcuzzi from University of Padova. And this is a joint work with Eric Chinellato and Paolo Martini. And the title is Real-Time Generation of a Targeted Clean Audio Sequence from Source Separation of Noisy Environmental Mixtures using a Deep Non-Negative Matrix Vectorization on IoT devices. So the motivation for this research is to monitor vibrating systems. And instead of using accelerometer sensing, we use microphones, which are cheaper, are non-contact, and have also other advantages like a wider band, for example, frequency band. Therefore, we monitor the system from the sound it emits. And humans have often monitored systems from emitted sounds. For example, railways have been monitored in the past by people walking along the line, hitting the rails with a hammer and listening. And the emitted sound is immersed into an environment, acoustic environment, that can have various and complex acoustic sources that we should separate to recover it. Here we have developed an ID device that automatically recognizes targeted clean sources within a mixture, for example, healthy sounds, failure sounds, and plays them in real time for a better recognition by the human. This is done by assuming almost additivity in spectrograms. Here you can see an example of a spectrogram generated by this machine tool. And from the spectrogram of the mixture, the system must recover the spectrogram of a possible combination of clean sources. And this is done by a matrix factorization and a low-rank approximation. Since the spectrogram is a matrix of non-negative values, so it is a non-negative matrix, we adopt the non-negative matrix factorization. Which is practically the fact that we have a given matrix X and we approximate it with the product of two matrices W and H. And it means that each column of X is expressed as the linear combination of the columns of W times the coefficients in the corresponding column of H. So it means that W is a representation basis and H is a matrix of coefficients. This problem is usually solved in an iterative way, and precisely by doing alternate optimization of the factors. So at each iteration, first is optimized H and W, and then H and W. So if we unfold these iterations, actually we construct the topology of a neural network, and we can, at this point, add a backpropagation learning to this numerical scheme, in the sense that we start from an initial estimate of W and H, and in the forward path, we optimize like the NMF do with this F function, and in the backward path, we use backpropagation. Backpropagation, so it becomes a neural network where the parameters of each layer are the entries of the matrix W. At the end, when we arrive to the convergence, we do a low-rank approximation, since a priori, by construction, our dictionary is made with the first columns that are basis functions for the clean sources, and the other n columns are basis for the noise. So we extract the first part, and this represents the clean sources component which is present in this mixture. For this algorithm, which is called deep NMF, the cost function that is applied at the end of the network is a Wiener filter. And there is another important fact about this, that the learning process must guarantee that the entries of the W matrix, so the network parameters, remains positive. So this is a non-standard backpropagation algorithm, which is made by this kind of gradient, which is described in the paper. This algorithm actually has been designed for speech enhancement, where the clean where the speech enhancement, where the clean sources are actually a voice, which is immersed in ambient noise, and the aim of this algorithm is to filter out the environment noise and to enhance the speech. Here, actually, our clean sources are the responses of physical systems. So we want to extract these clean sources exactly. So we added some physics-aware enhancements, like to reformulate the dictionaries as matrices with a Henkel structure that enforces the time correlation, which is typical of a physical system. We enforce this Henkel structure by projecting in all the backpropagation process the projection of the coefficients into an Henkel structure. And also we modified the cost function by adding to the winner filter term a term that enforces the fact that the resulting matrix factorization is represents as much as possible the clean sources present in the mixture. This is described in a submitted article that sorry. Then we did a step further, and we developed a linear model constructed using a Bayesian formulation of the noise present in the mixture. So from the mixture, we compute the pad NMF, we get the matrix of coefficients H. From this matrix, by doing geometric means, we get detection indices for each of the clean source, but this, even during training, these indices cannot be exact because the noise present in the mixture is not exactly representable by our basis functions of the noise. These are approximate. And also, the additivity in the spectrogram of the sources is not exact. So, but during the supervised learning that we are doing, actually, we know the exact values for the indices that the indices should have. And in this way, during the training, we tune a linear model, this map A hat, that is used then in the recognition phase as the model inverse from going to the mixture with the path the NMF to the matrix H of coefficients. Then we compute the detection index, and then with the inverse model, we get a better version of the indices. So we developed the hardware for this system, which is basically a microcontroller and a microphone, a jack for the headphones. And obviously, these kind of algorithms are quite mathematically intensive, and some issues arise. For example, numerical accuracy, you don't have the double precision of the PC. Computing power is not the same as the PC. You don't have libraries, so LAPACK is not available in this way. The debug and the timings should be made by using an oscilloscope. So actually, there is a big effort on developing this algorithm, and it makes sense only when you have a broad applicability. But this algorithm actually have it because it is completely parametric. So the total number of frequency buckets, for example, is a parameter. And it means that we can do this analysis in the whole spectrum, the whole spectrum, or a part of it, or only a band of frequencies. It depends on the application. So the time instance can be more or less depending on the windowing and the things that you use to do the STFT, the number of layers in the network, and so on. So depending on this parameter, we can compute the computational complexity, because if we want that this algorithm works in real time, of the pad NMF, of the heat detection, of the signal generation. And actually, we found that even an ARM4 microcontroller is able to do quite a nice work, and an ARM7 is better, okay? And in the sense that processing 1 second of signal, they perform the overall algorithm in less than 1 second, so they are real time. So I want to conclude with showing you an example of functioning of this thing. So we have a mixture here, which has been collected by playing a music with a lot of instruments, percussive instruments, instruments that make frequency sweeps like this that are very confusing for the algorithm. And in this loud music, we played piano notes, okay, softly, like a C4 and E4 and G4 sometimes, okay? And the system should recover these notes. So we have the clean sources for the notes, we have the sources, an approximate description of the environment noise, which is the music, so patterns taken in some places of the music. And then we see this plot of the indexes that I showed you before, where, for example, here it is played the C4 note, and the asterisk is the index for that clean source, and you see that actually is quite above the threshold that is computed for this application, and it is the maximum of the three. So this indicates that actually the note was played here and it recognized it. So in this instance, there were no notes played, only music, and actually the indicators of the clean sources were well below the threshold. Consider that this is a logarithmic scale. And this is for the E4, the G4, and you see that actually there is a quite good separation between the true events and there is no false event. Okay, so it is quite reliable on doing the aim that I told at the beginning. And I thank you for your attention.
Thank you so much, sir. Ma'am, do you have any questions?
Yes, Fabio.
Yeah.
Yeah, I like your work. It's a nice work. I just have one question. Like, what was the motivation behind choosing this research or this topic?
Sorry, I lost the
How did you
beginning.
choose this research topic, and what made you to go for this piano music and loud music with the IoT devices? What was that motivation behind making this research?
Okay, the motivation is, okay, it's a nice application and it is a cheap laboratory because you have a piano, you have a stereo playing and that's all. Okay, if you want to use a machine tool or something like industrial equipment, is actually much more costly. And this is pretty nice because you have at disposal a laboratory of a lot of kind of sounds. You can do all the things of experiment, the kind of experiment that you can do. There are also beautiful applications because actually this could be something that can okay, write, okay, recognize the music, the scale, and so on. Okay.
So may I know the role of IoT in this?
Yeah. Well, the role of it, well, actually, I pointed out much the mathematical terms, but this system that I showed you actually is, okay, here you have a demo board, below you have a demo board with an ARM7, but this could be even an ESP, okay, so a processor with a Wi-Fi mounted, and it becomes a very small IoT component. And the fact that we want to reproduce the signal is for people, but actually here there is the recognition phase that produces events that can be transmitted to with the Wi-Fi to a server that is monitoring many machines or something like this, for example. And the two things can be done also simultaneously.
All right. Thank you, Fabi.
Okay, thank you. Bye.
Thank you so much, sir, for your presentation. So we may move ahead with our next presentation. Next up, we have Timia to present the paper titled Transformative Insights of Sentiment Analysis with Explainable Transformable Models. Are you there?
Yes, I'm here.
Okay, you may start with the presentation.
Okay, let me just share my screen. Okay. I hope my screen is visible.
Yeah, it is. You may start.
All right. Okay, thank you very much. So I'm going to present our work based on the topic transformative insight of sentiment analysis with explainable transformer models. And the paper is prepared by me. My name is Timia Bezdan, this Ali Hodžić, Professor Eva Tuba, and lastly but not least, Professor Milan Tuba. About the introduction part nowadays, because of the internet and different digital platforms, like different social media platforms, the number of the text-based documents and content is growing exponentially, and it requires to have an efficient method that is going to analyze and make the sentiment analysis automatically, because it's basically impossible to do it manually, to read it, and it will be also subjective. And on the other hand, we need a method that is going to also explain why the model made a certain decision, because usually when from the businesses, from marketing or management, they are requiring something, they are also requiring like explanation why the model made some decisions. So that's why explainable AI is very important nowadays. About the objective of our paper, first, we are evaluating and comparing the effectiveness of different transformer models like the Distilbert, Electra, T5, ERNIE, GPT-2. We selected these because each of them has some specific things that is good for sentiment analysis, and the transformer models are the like the latest, the best for the NLP, for natural language processing. And there is also like in work from GPT-2, I mean, like most of you know, there is 3.5, 4, and 4.0, just recently introduced, but we use this one because this is, it's free and it doesn't require an API or something else, and we can fine tune it. Then we made the comparative analysis to compare it to some existing method. And for the comparison purposes, we use different metrics like accuracy, precision, recall, and also the harmonic mean of the precision and the recall, which is the F1 score. The general architecture about the transformers model is what you can see, which have two main phases or two main parts. One is the embedding, and the another one is, the encoder, and the another one is the decoder structure. So we have an input, and then we are inputting the embedding. Then there is the positional encoding, so which word is on which position. Then it is then the self-attention is used, which is very important because of the dependencies between the different words, which was introduced in the famous paper, The Attention is All You Need. Then there is the normalization, then it is flattened out to use the feed-forward network, then the decoding part starts. And then finally we have by the softmax and getting the output in case of the natural language processing. And by introducing these transformers, it gets a big attention because the results are got very good comparing to some existing model in different problems of natural language processing. And that's the reason why we tried also for sentiment analysis and comparing to some other existing techniques. About the distal bird, it is like smaller and faster version of the bird. So that's why we selected, because it is very similar to the bird, but the execution is much faster, which is also important about the time. Then Electra uses a discriminator for token replacement. Then T5 is a bit different. It converts the text into text-to-text format. ERNIE is integrating the word knowledge into pre-training, and we fine-tuned also ChatGPT-2. It's generally used for generative AI, but we use it, we fine-tuned it and use for sentiment analysis, classifying like negative or positive sentiment in the text. About the data set that we used is the Amazon product review data set, where there are 3,000 reviews. There is We used the portion of that because of faster training. We use Google Collaboratory by using the GPU, the T4, the Tesla T4. So we took from those 500 positive and 500 negative sentiment, and also did the comparative analysis of performance metrics comparing to some other methods that are used on the same data set. And also additionally, which is also like another thing what we achieved is to get the attention, to use the attention mechanism to explain why specific model made some decision, whether the sentiment is positive or the sentiment is negative. So here you can see different models like the globe, the Virtu vector. So those are some basic methods that are used at the beginning in general for sentiment analysis, also the BERT, the LeBERT, and these other methods that we use from the transformers, the DistilBERT, Electra T5, Ernie, and the GPT-2, which is fine-tuned for sentiment analysis. Then you can see here the comparison of the accuracy, precision, and the recall, and the harmonic mean of the precision and the recall, which is the F1 score. You can see those basic like embeddings, like the globe or the LeGlobe, Virtu vector. Those are giving like not so good results. So the accuracy a bit less than 80%, and also like the precision is about 80%. Then there's another methods like the BERT, is a bit more than 0.8 or 81 and 82% about the accuracy. And you can see these transformers models that we applied, we are getting much better results on the accuracy. For example, on the DistilBERT, which is like a version of the BERT, it's increasing like by 11% the accuracy. And you can see the notable result of the GPT-2, which is 94.5%. The accuracy on the T5, we got the highest precision, and on the Electra, we got the highest recall. So it has 0.97, almost 0.98 or 98%. So you can see that it's very good in predicting the positive sentiments and also the F1 score. So to get the harmonic mean of the precision as the recall is the best with the utilization of the GPT-2 method. Then here you can see some examples of the visualization of the attention mechanism. So how the model come to the decision why it is made some positive or some negative sentiments. And for example, in case of the positive sentiments, you can see that the nice and extremely are highlighted the most. While on the other hand, when we are talking about the negative sentiment, for example, you can see that the word horrible is highlighted the most, so it clearly gives also the decision, why the decision is made by the model in case of the positive and the negative sentiment. And that's the case also with the another sentences, but we just included two of them. So in general, about the key findings of our work is that GPT-2 superior performances in the sentiment analysis. Then Electra has a high recall rate, so it's very useful for capturing the positive sentiment. Then T5, the text-to-text model, is very good in versatility in handling various sentiment analysis tasks. And this works balance between the performance and the efficiency, because as I already said, that the DistilBERT is very much faster, for example, than the BERT method. And to conclude our work, the transformer model significantly enhances the sentiment analysis. It's also improved the accuracy and also additionally the interpretability, which is becoming very important nowadays, and the potential application in e-commerce and social media analytics to make easy to analyze on different products, for example, or different posts in social media, the sentiment, whether it is positive or negative, and also there is potential to automatize it. So it helps, for example, marketing managers or managers in e-commerce to make some decision. And about our future direction. So our future work is to explore more different transformer models and also to fine-tune different models for specific domains. This was particularly on the Amazon product review, but maybe in different e-commerce platform also to use it, and also to investigate the integration of some additional explainable AI techniques. For example, like to use the SHAP, the Shapley explainable AI method also, because that is also used in a natural language processing and NLP, highlighting the words why it is making some decision, and also it have nice insight about the decision of the model. So that is about our work. Do you have any question?
Thank you so much. Ma'am, do you have any questions?
Yeah, Timia.
Yes.
Yeah, it's I understand it's a comparative analysis as of now. Am I right?
Right.
Yeah. So in the future, you can come up with your own method for sentiment analysis. I mean, you can do some implementation details and come with your methodology.
Yeah, so we are trying to find what is the best methodology for specific domain, because like the no free lunch theorem applies also here. There is like no best model for all of the problem. So like automatically to detect for which domain to use which algorithm, and also from the business point of view, they are always requiring, so it is explainable to find a model which has also like explainable AI component.
All right. And this Amazon reviews, the one which you have taken. So this reviews was about a particular product, or?
Yes, in general about different products on the Amazon. So there are product reviews by the customers, and this is publicly available data set we just use for benchmarking, like a benchmark data set. And we are going to also apply it to another real world problems as well. But first, we also always need to do benchmarking. Yeah.
Are you doing research? Are you a PhD scholar?
Yes, I just completed my PhD recently.
All right, that's nice. All right, all the best for your future.
Thank you very much.
Thank you. So now I would like to sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for your support during this 8th version and all the previous 7 versions of the conference held in the Asia. We will be happy to have you in the 9th version in 2025. All the presenters would be getting the digital certificates through email within 2 working days. Further, all the papers have already been forwarded to Sprinter. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2024. I would also like to thank our session chair for chairing this session. Sir, do you have any closing remarks?
Thank you, ICTIS, for their invitation and for the nice session, and all the participants, all the researcher, and also the session chair Preeti, Dr. Preeti, for sharing the session. And this is the enjoying thing. Thank you all.
Thank you so much, sir, for your presence. I would also like to thank our session chair, Professor Preeti Parvekar, for her delightful presence. And this is a token of appreciation to the chair on the behalf of the whole team of ICTIS 2024 and the organizing partners. Ma'am, do you have any closing remarks for us?
Yeah, thank you, Anchita. And thank you for giving me opportunity to be a session chair. And it was really nice to listen to all the different point of views in different domains from all the authors. And thank you, sir, the other session chair who is with me. And it's good to see and meet everyone virtually. So thank you.
Thank you so much, ma'am. So thank you for your valuable presence. Now I would like everyone to please open their camera for a quick snapshot. Can everyone please open their camera? Okay. Thank you so much, everyone. We'll be starting the next session in 5 to 10 minutes. Kindly join with the same link. Thank you.